All right, so this activity, confidence intervals, means with sigma unknown. So it's an instance where we don't know the population standard deviation, and we have to work off of the sample standard deviation. All right, so just a couple of quick examples. George is attempting to find out how many text messages the average John Jay student sends in a month. He takes an SRS, simple random sample of 15 students, and gets the following numbers. So my sample mean is just going to be the average of those particular values. So I'll just do average, boom, lock it in. Sample standard deviation, same idea. All right. So in terms of the approach that we're going to take here, there's not really that much that's too different from the previous activity. So same idea. We want the confidence interval. Let me, just in the habit of making some edits here. So actually, I got an idea. Let me steal some of my previous stuff here from the other activity. All right. So just pop that in right there. Font wise, it's probably a little big. So for consistency. Now this one said in particular to do a 95% confidence interval. So that's all we're gonna do. We don't have to do the other ones in this case. All right. But it's really a similar approach, right? So the mean of the sampling means is gonna be the same as the sample mean itself. And the standard error is gonna be this number, so equals this number divided by the square root of 15, right? But I'll use a count. Square root of the count of all the items in this area here. All right. The 0.05, it's a little different. We have to use an inverse t, right? So this is a t distribution because we don't know the population standard deviation. I'm going to steal, just like I did in the other activity, I'm going to steal the coding here. All right, so I'll explain it. So this is a t inverse instead of an inverse norm. All right, inverse of a normal distribution was for the case where we knew sigma. Inverse t distribution is the case where we don't. All right, and so all I'm doing here is I'm applying the absolute value because I only want a positive number. 0.05, that corresponds with my confidence level. Right, so the alpha value is 0.05, right, and then we counted B2 to P2, and it's always, so we divide by, or we incorporate what's known as the degrees of freedom. Degrees of freedom is always one less than whatever the total number of values is, right? So in this case, just like for the previous activity, the only thing that you would ever have to edit would be this number here, depending on what your confidence level is. All right, so lock that in. We get our low bound, high bounds, right? And in fact, if you really want to do it, you can go right to that previous activity and take the coding and even the concatenation and just edit as needed, right? So this is definitely not the right number because the references are all out of whack, but I need my mean of the sample means, which is in C7. My standard error is in C8. And my critical value, that 2.145, that's in B11. All right, so it looks like I have it. Then copy paste and update minus to a plus. So now we have an interval with 95% confidence that we can say captures the population mean number of texts. Right? And again, I'm going to steal my concatenation here and edit as needed. Right? Never a bad idea to keep in mind. Okay, so have I done this before? You know, and if you have, then make use of the work that you did previously. If not, then different story. All right, so we are blank confident. My confidence values in B10. And it's not mean price of a home, it's the mean number of texts. is between, I have it in A13 and B13. All right, and let's just see. Oh, it's not dollar signs anymore because we're not talking about money. All right, and again, if you want to do some rounding, go for it, but not a requirement. All right, and you can see that the next problem, very similar to this one, right? Structured it a little bit differently, right? So the sample mean, so equals average. Pulling right from my data set. Sample standard deviation. Mean of the sample means, that's equal to the sample mean itself, equals, and then same idea for standard error. And in fact, just going back, like I said before, take the work that you've already done and just update it as needed. All right, so my H20, that's where I have my value. Okay, so count from A20 to A65. All right, so it looks good there. We're doing 99% confidence. Which corresponds to a 0.01. All right, so steal my work over here. I'm gonna update. It's gonna go from 0.05 to 0.01. And again, it's going from A20 to A65. So I'll make that update. All right, low bound, high bound. In fact, why not, right? Just take it all. All right, so my low bound, we're looking at H19, oh, sorry, H21, and this is in D25, so that's good. And then H22. So that's my low bound. And my upper bound. Minus goes to a plus. And now we have it. Now this actually goes back to the dollar value. So mean price of homes. Is between $sign and $sign. It looks the way I want, and again, if you want to, play around with rounding, totally fine. You could also leave it like this. Just make sure your units are right, because if we're talking about number of texts, it shouldn't have $signs. If we're talking about money, it should. All right, and there you go.